All right. So this morning we are going to talk about the HH8 heat pump. If you missed few weeks ago or last month, the A2L presentation that I did, I will be redoing that in 2 weeks from today on the 15th of this month. I will be doing another version of this or another live version of this. So in case you want to rewatch it, if you want, or know somebody who needs to see it or wants to see it, I will be doing this here again in 2 weeks on the full A2L and the new product update. But for today, we're going to talk about the HH8 heat pump, which is an A2L or an R454B heat pump. So this is what we are going to be stocking as our heat pump for this year or for the coming years. So the HH8 is the R454B outdoor 18 SEER 2 heat pump. It is a variable capacity. It is not a mini split. It is a variable capacity outdoor unit. So it is not a Mitsubishi or Agree mini split. This is a heat pump, just a basically standard heat pump, but it uses the variable capacity to regulate itself so that we get the proper heating and cooling out of it. So the HH8, the nomenclature on it, the H means it is a horizontal discharge unit. The second H means it is a heat pump. The 8 means it is up to an 18 SEER 2, the capacity. And then the next is the E, which means it is an R454B unit. The R410A units prior were Bs. So these you'll see E, followed then by the voltage, the control strategy, which these are just standard. They just use a standard heat pump thermostat. And then the last one and ones are just accessories and options and any version change. Now on these, if you look at the very top, the nomenclature, it's an HH8 824, an HH8 836, and an HH860. There is no 48 because the 60 is variable. With the flip of a dip switch, we can change this 60 to a 48. So there's actually 3 different units to make up the 4 different ranges. So these do use R454B, excuse me, A2L low GWP refrigerant. For those of you that use the HH8 the kit is gone. You won't need that kit anymore. And we return to using the O terminal instead of the B. So that's why one of the reasons we don't need to have the kit anymore. And there is no S terminal on it. So we're going to regulate that between the Y1 and the Y2s. You can, by the flip of a dip switch, we can change the output readings to Fahrenheit and PSI readings. If you remember on the HM87, everything was in Celsius. These come in Celsius, but with the flip of a dip switch, we can change these to Fahrenheit. The service valves on the 2 and 5 ton come out at a 45-degree angle, which makes it easier for access. The 3 ton comes right straight out, and we'll talk a little bit more about that. The line set access are longer so that you can use the RLS fittings on them. They do come with a swedge on them, so you would have to cut that off if you're going to use the RLS fittings on them. Once again, there's 3 models. The 60 can convert to the 48 with the flip of a dip switch. And we're just going to use any heat pump thermostat. If you're using it with a furnace, you do need to have a outdoor sensor to go along with that thermostat. I get some feedback, somebody. Okay, so here's the layout of the service valves for the 2 and the 5 ton. They come off at a 45-degree angle. They do have, like I said, the swage on the end, so if you're using the RLS fittings, you will need to cut those off. The 3 ton, however, they come right straight out. So when the first versions came out, and we have some of those or had some of those, you'll see the layout on the left, the access to them to get your hoses on and stuff were not ideal, to put it plainly. They were accessible, but they took a little bit of, they weren't easily to get to. And they realized that once they came out with the units. So in August of this month, the units built in August and after will have a modified access, which is to the right there. So they will come off at a 90-degree angle so that you can put your hoses and such on there, your pressure sensors and things like that. So the ones we have right now, unfortunately, they are the ones that are on the left. So there is nothing wrong with them as far as functionality or anything. They're just not the easiest to get to. So the new ones, when we get them, should have the new design changed to them. The operating conditions on cooling, we can go down to 35 degrees outdoor temperature. Now that doesn't mean we're getting 100% capacity, but that is what we can get the thing to run down to. On the heating side, once again, not full capacity, but it will heat down to 13 degrees below. Some of the physical and electrical characteristics on it. One of the things to be aware of is make sure that you're looking at the minimum circuit ampacity and the maximum overcurrent device. Your minimum circuit ampacity has to deal with your wire size, and your maximum overcurrent device is your breaker size. These on the larger sizes are a different size than what you were using with the HM87. So be aware of the fact that you do need to look at this to make sure you do have the proper wire size and the proper breakers. The compressors in these are twin rotary compressors, which a lot of the variable speed or variable capacities compressors are. The other thing is need to look at is the unit charge. This is what comes in the unit. And then we also need to look at the refrigerant service valve size, which means this is the size line set that you need to use. On the 2 ton, you're going to need a 3/8, 5/8 line set. On the 3 ton, it's a 3/8, 3/4, and on the 4/5, it's 3/8, 7/8. So be aware on the 2 ton, it needs to be a 3/8, 5/8 line set on it, which is what we used with the HM87. So that is not any different. But if you're just getting into using heat pumps, be aware of that fact. Okay, on these, they're going to come charged with 15-foot of line set, just like all the rest of the units, but we can go a long distance with these. We can go up to 164 feet with the 2 ton. We can go up to 200 feet with the 3 ton, and the 4/5 we can go to 246. Well, that doesn't mean that we want to set it at one end of the building and have the furnace at the other end. On our additional refrigerant charges, be aware of this, please, because we're looking at, oops, there we go, different adders. Because we're using 454B, It's not the exact same as the R410A because our 454B has a little less performance, a little more, oh, sorry, a little less charge needed. So we're going to add a little bit less refrigerant. So at the 2-ton, we're going to look at 0.54 ounces per foot over 15 feet, 0.57 on the 3-ton, and then we're back to our 0.60 on the 4-5-ton unit. So be aware of that there is a little bit different charge. It's not a lot. In a short distance, it's not going to be a huge amount, but these do need to be aware of the fact that they are a little different than what we are used to, just a little bit less than what we had before. If you're using an elbow, and when I say an elbow, this is a physical elbow. This is not a bend in the line. But if you're using an actual elbow, you do need to add in a little bit for each one of those elbows if you need to figure out, want to use your exact length of pipe. So we have matches here with the JCI, the York Lux Air coils. These are what we have in, what we're going to be using for our coils, are the JCI coils. So these will be a matched system between the outdoor unit and the indoor coil. The indoor metering device on the 2-ton is going to use the A TXV, and the 3 and 5-ton will use the C. The coils will come with the TXV already pre-installed. And it is in the nomenclature of the coil of whether it uses the A or the C TXV. Those are the only 2 TXV sizes that are going to be used now. They are not, however, the same TXV that we're using for the 410As. So we do need to be aware of that, as these are 454B units, so they're not the same. So let's just take an example here. Let's have the new coils will be a CT coil. So if we're looking at the CTF coil, and let's say we put a 3-ton coil on a 2-ton unit, we're going to have to add 11.2 ounces to our charge to make up for that larger coil. If we're using this coil on a 3-ton unit, we don't need to add anything in because of the match is evened up. And of course, we don't want to use a 3-ton coil on a 5-ton. That's just not going to work. Okay, so charging. We're going to check the unit factory charge listed on the unit nameplate to verify the refrigerant charge for the outdoor unit. We're going to look at the smallest matched indoor unit and 15 foot of line set. That is what comes charged in the unit. We're going to verify that we have the indoor metering device, once again, the A or the C, and additional charge required for the specific matched indoor unit in the system using the table. We're going to release the refrigerant into the system. We're going to open the liquid line service valve first, then we're going to open up the vapor line service valve. We're going to add any additional charge to the amount already in the unit for anything over 15 feet of line set. Then we're going to add any additional charge if needed for the indoor coil. Once again, if we oversize the coil, we do have to add some additional refrigerant. Then after weighing in the charge adders for the indoor coil, the refrigerant piping, verify the system operation, and allow 10 minutes after each charge adjustment for the system to operate to stabilize. This is, if you notice, this is nothing different than what you're doing today. What is going to be different is you will be required, this was recommended before, but with the new A2L refrigerants, this is a requirement that you must permanently stamp. So you're going to have to carry a marker with you, permanent marker with you. So we permanently stamp the unit nameplate with the total system charge. which is the base charge, how it came charged with, if we added any refrigerant for the indoor coil, and any refrigerant we added because we're over 15 feet of line set. If we're under 15 feet of line set, we're going to have to take some out. But this does need to be, and this, once again, this is a requirement for the new A2Ls. You must mark on the unit the amount of refrigerant that's supposed to be in that unit, the amount of refrigerant that you added or the charge that was in there when you left. Okay, now I said that we can go up to long distances with these units, but we have to keep in mind when we go long distance, we're going to lose some of the capacity. So at a 25-foot line set, we're losing nothing. Let's say we go to a 50-foot line set, and on the 2-ton, we're going to lose about 7%. On the 3 and 5-ton, we're going to lose about 3%. Not a huge amount. This is basically what we're losing in performance on what we're using today. However, if you want to have the 5-ton and you want to go the full 246 feet, you're going to lose 35% of the output of that unit. So you're not going to get all 5-ton out of that. You're going to lose 35% of that. So need to be aware of that fact if you want to use those long distances, and you're sizing these down to where they're very accurate on the size. Make sure you're aware of the fact that as you get longer line sets, you are going to lose some of the capacity. If you're going a distance vertically more than 16 feet on these units, you do need to add traps on them. So to install the oil trap in the vapor line, you're going to measure 16 feet. You're going to insert the oil trap at that 16-foot level. If the vapor line is longer than 16 feet, you'll have to do it every 16 feet in elevation. Usually not a great issue to go with this. We do need to know the clearances, how far away or how close we can have to be from the house or from a bush or anything that can interfere with the unit. So if we're looking at the back end of it, it says over 8 inches. On the end, it says 14 inches, and in front 20 inches. One thing to keep in mind for the service guys is tell your installation guys, make sure you have enough room, so if you have to go back for service, that you've got room to be able to do that. You know, these are still need to have service done to them, still need to have the coils cleaned and such. So while our dimensions are close, make sure we leave enough room so we can get into it, so we can work on these things if necessary. Hey, different types of installations, ground installation. Remember, these are heat pumps. They need to be up off the ground. When they go into defrost, they're going to drain water, and we got to have some place for that water to go. So they got to be up off the ground, above the snow level, so that when it goes into a defrost mode, that water can run away from it. Roof installation, same thing. It's a heat pump, so we still got to be up in the air. Make sure that it is properly anchored. Make sure that even though it's anchored to the, if you're using a frame, make sure that frame is anchored. And wall mount installation, same thing. Make sure when we put them up, we got to have these things up off the ground so that they can drain when they go into a defrost. And if necessary, you say you're near a sidewalk or something like that, it does come with a drain elbow that you can put on that, so that you can put that and put a hose on there, make sure the hose drains, to get the water away from it if necessary, if you can't just let it drain where it is sitting at. All right, so any questions at this time? If you do, you can put it in the chat. You can raise your hand, or you have the capability of unmuting yourself if you need to ask any questions. So at this point, any questions up to this point? Okay, I don't see anything, so we will continue on with our electrical connections. Okay, so we're going to have high voltage, of course, and we're going to have our thermostat connections. So if we're looking at the, oops, sorry, 2-ton unit here, we don't want to cross our high voltage with our low voltage. So our power supply wires are going to come in on the right-hand side, our low voltage wires on the left-hand side, so we're not crossing the wires. On the 3-ton, the electrical connections are closer to the bottom, but similar thing is our power is going to be on the bottom. Our thermostat wires are going to be in the opening right above it. And on the 5-ton, they actually come in kind of halfway up. So once again, our low voltage wires now are going to be on the bottom, and our high voltage would be on the top side. And once again, that's the purpose is just so that we're not crossing our high voltage with our low voltage, just like what we're doing today. And here's our connections. You'll see we have our common G or O terminal, Y1, Y/Y2, and our W's there. One thing that is going to come into play is an RDS, refrigerant detection system. So if you're in the A2L webinar a few weeks ago, we talked a little more about this, and once again, I'll be talking again about it in a couple weeks. But you need to be aware of this is a requirement on our heat pumps. Any system with over 4 pounds of refrigerant has to have this RDS system. All the heat pumps are going to have more than 4 pounds, so these will be required. Now these will come with the indoor coil. There will be a box on there. It's mounted on the coil. That's not where it goes. It's there just for shipping purposes. So you'll take that box off. You can mount it on the side of the coil. Just be careful you don't poke the coil. On the side of the furnace, or you can mount it on the wall. It doesn't matter, but it has to go between your thermostat wires and the connections to the furnace or your air handler. So what this box does is we mount this and we have our thermostat wire connections come into the control board. And coming out of the control board, there's a system wiring harness. This mounts, comes off of the board and will go into our furnace or our air handler. So this has to be mounted between our thermostat and our control board on our furnace or air handler. There is an RDS sensor pre-mounted in the coil. You don't need to move it. It is in the position it needs to be, whether it's in upflow, downflow, horizontal, left or right. It is in the position it is, so you don't need to move it. But coming off of that, there is a connection which will go down and it'll plug into the RDS control board. So positioning the RDS control board has to be so that that wire coming off of that can plug into that board. You don't cut the wire, you don't splice the wire. You need to leave the wire intact. Whether it's too long, just loop it up. Don't mount your control board farther away than what that wire that comes with it. There should be plenty of wire that you can mount it in multiple places, but you cannot cut or splice that. So what happens is if it would sense a refrigerant leak, it's going to shut down the Y terminal or the W terminal is going to shut down your heating or cooling, and it's going to energize the fan. So it's going to energize the fan. So we're adding air to it. We're diluting the leaking refrigerant, so it is less harmful. We're not that 454B is highly flammable. It is considered a mildly flammable refrigerant, but once again, it's not very flammable. But it does fall in the classification of an A2L, which means it's mildly flammable. So that's the reason we have to have these sensors on here. So we hook into our thermostat into the board. We come off of the board with the system wiring harness, and that's what goes to our furnace control board. Okay, so on the mitigation control board, it has a G output, and there's also an A2L output. On the new furnaces that are out and coming out, the Y81s, the Z8ESs, basically anything that starts with or the new furnaces that are coming out, these have a terminal on there for this A2L. So on any other furnace or any other air handler, you're going to use the green G output wire. On these furnaces, you're going to use the green with the black stripe A2L, and you will connect that to the G terminal. So if you're using any furnace other than the new version of furnaces, you will use the G wire. On the new version of furnaces, you will use the A2L wire instead of the G wire to hook it up. The reason for that is just what's built into the boards. The new boards, the new furnaces have a capability of picking up a different signal. So these can go on any furnace that's out there, whether it be a York, a Luxair, a Train, a Carrier. These will work on any of those systems with that control board, because all it's doing is just breaking up your thermostat connections. And if you're using a furnace, once again, make sure your thermostat has fossil fuel capability, which means you're going to have a thermostat with an outdoor sensor so you can set a balance point. So here's the control wiring with a standard ECM gas furnace. So it shows the mitigation board in between there. Once again, it's not a big deal. And this is how you're going to wire it. On our heat pump outdoors, we have our O terminal, a W terminal. The W turns on our furnace when it goes into defrost. We have a Y1 and a Y/Y2. The one thing that that we need to be aware of is on these boards, both dip switches on the mitigation board must be in the 1 or the on position. So when we're dealing with a furnace, both dip switches need to be in the on position. On a variable ECM furnace, such as the YP9C or LP9C, this is going to be our connections. If we Sorry about this. For some reason, my program just shut down on me. Everybody still able to hear me?
Yeah, we can hear you.
Okay. I don't know what happened there. The program just shut down. So let's get back to where we were. Here we go. So on the variable ECM, there we go. YP9C, LP9C. Once again, I'm going to wire it up. The only difference is the YP9C or LP9C has or the TM9V has an O terminal on the control board. So we do need to hook up the O terminal on the control board in the furnace. Once again, the dip switches both dip switches and the mitigation board need to be turned to the on position. And if we're using the newer furnaces, instead of hooking the G from the mitigation board, we're going to use the A2L terminal over to our furnace control. If we're using this with the standard standard air handler, we have a different connection. Notice down below, if we have the new JHE air handler, both dip switches must be in the off position. And also on the new JME, which is the modular air handler, both dip switches must be in the off position. Other than those two air handlers, those dip switches will both be turned to the on position. All right, so on the HH8 heat pump, we have some dip switch settings. So we're going to look at switch bank S4 and S5. So from the factory, those dip switches are all going to. We have the option of changing the dip switches. We can actually pump down the system. So basically we can close our service valve and we can pump refrigerant back into the unit. However, if we've added refrigerant to it, we have limited capacity, so you're not going to be able to pump everything back into it. It's meant to pump the refrigerant that it came with back into the unit, so you could pump it down so you wouldn't have to recover it. When you're doing, if you have to repair a leak or something like that, you can pump the refrigerant or the big share of the refrigerant back into the unit. If you're doing a service, you can put it into a forced defrost by using the dip switches. On switch bank number 5, what we're going to use is the capacity high to low. This is going to be on our 5-ton unit. To change it to a 4-ton unit, we're going to change the dip switch. And if for some reason you don't want it to be a heat pump, you want it to be cooling only, you can change that too. So if we look at switch bank number 4, the first switch, this is what changes our readouts from Celsius to Fahrenheit and puts our pressures into pounds per square inch. So from the factory, this position will be off, which means it's going to read out Celsius. So we just need to change this to the on position. So to do that, we're going to remove the heating or cool coil. So it's just in standby position. We're going to open the door up and we're going to change number 1 from the off position to the on. On our chain, then we will change, then our readings will be read in Fahrenheit and PSI. To activate the lower capacity on our 5-ton unit, once again, we're going to change dip switch number 5 on switch bank S5. So to do that, we got to kill power to it. We'll kill power to it, allow time for the control board display to go blank. So these have capacitors in them. They're variable capacity. So when you kill power, there is still charge in there. Those capacitors have to discharge. So make sure you wait until the control board goes blank. There's roughly 300 volts DC in the control boards. So you don't want to just kill power and quick grab hold of something. You might get a little bit of an awakening. So make sure you allow time for make that the display goes blank. Then we're going to open the panel up, and we're going to change dip switch number 1 on S5 to the on position, and then we can power it up. And now we've changed this unit from a 5-ton unit to our 4-ton unit. Okay, so in the units, all the units, there is a little panel in here. This is our display panel. So this has 3 buttons on it. It has S1, which is our select, S2, which is to raise it, increase it, S3 to drop down or decrease our readings. So to run a parameter inquiry on the units, press the S1 button to display the outdoor unit parameter. P indicates the parameter on the outdoor unit. So for an example, P0 is the parameter code for outdoor unit fault codes or protection codes. And P1 is the parameter code for compressor actual frequency. We use S2 and S3 buttons to either go up or go down on our parameter number to get to where we want to. So as an example, if we're at P14, that gives us what our AC input current is running. Press S2 to increase the parameter number. We can press and hold it, and that will run that number up fairly rapidly. And if you bypass, you press S3 to bring it back down to where you want it to be. You're going to wait for 3 seconds, and then the parameter will come up automatically with the display on there. When the parameter displays the P0 parameter code, E displays with the outdoor unit fault code or protection code, for example, an E13. So if there are multiple outdoor fault codes, the codes will display in the sequence of most recent to the oldest one. So on the parameter side, our P0 gives us any fault codes that we'd have on there. So if we go to P0, it should give us an E with the fault code on there. If we want to see what the compressor actual frequency is running, what hertz rating it's running at, we push the parameter P1. If we want to see what the discharge temperature on the compressor is, we'll go down to P5. The outdoor suction temperature is P6. Outdoor ambient temperature is P7. Our outdoor coil temperature is P8. Our outdoor defrosting temperature is P9. And if we want to continue on, we can see what our AC input current is, our AC input voltage. So we can see a lot of what's going on through that little display board. So we can see what we've got there going on. Once again, use caution when working with these drives. They do have a little bit of an oomph to it, up to 300, plus or minus a little bit, 300 volts DC. So be very careful if you're working on this when it's live. Okay, so if we look at the control board for the 2-ton, it includes the main control board with an integrated drive board. So if we look at the board, we've got our sensors plugs into them. They're different sized, different colored. So hopefully, if we have to replace it or replace one of the sensors or things like that, they are color coded, they're size coded so that we can't plug them into the wrong position. On the 3 and 5-ton unit, it's a different board. We will have a main control board, and we will have a separate filter or drive board to go with it. Once again, it's very easy. Everything plugs into it, color coded. On the 3 and 5-ton, we have a separate board. This is our filter board or our drive board. So there is not much there. Gives us our AC voltage in, our line voltage, and then it puts it back out. On our sensors, we have a couple different sensors as far as ohm reading on them. So we have a chart here. This is our discharge temperature sensor, which comes off our compressor. So because our temperature coming out of our compressor is going to be a higher temperature, we're using a different sensor. We have a different sensor for our outdoor and coil temperature. These are the same as far as our ohm reading versus our temperature. So if we need to check a sensor, we're going to unplug it. We got to know what temperature it's reading, and then we can ohm it out, go to the chart, and see if it's reading the correct ohm reading on it. So let's just say we go to 30 degrees Celsius, the chart's in Celsius, 30 degrees Celsius, and we ohm out the sensor. It should be reading the R nominal. So it should be reading 4.55 kilo ohms or 4,550 ohms. So we can check the sensor there. Or the easier way to check it is if we go right back up here on our parameters, we want to know what that outdoor ambient temperature is. We just go to P7 and it'll tell us what it's reading. If it's 50 degrees outside and it's reading 200, I think we know where the problem's at. So it's very simple to use the little board to do troubleshooting and to see what's going on with the system. Okay, so viewing the fault codes. For the 2-ton, the 7-segment display gives us our outdoor fault codes and protection codes, and there are LEDs. There's 3 LEDs on the main control board. This is if we have a fault with the drive itself. So we have LED 1 gives us the tens place, our LED 2 is the ones place, and if LED 3 is lit, then this is when we need to look at it because that gives us that we have a fault with our drive. On the 3-ton unit, on the board, we have 3 LED lights. The upper flashes the first digit of the fault code. The middle flashes the second digit. So on a fault code 13, the top LED will flash once. The middle LED will flash 3 times. A fault code 13 is a trip of the compressor overheat protection switch. And down in the bottom, it says it'll show an E13 for our fault code to go with that. So let's say we have a fault code 43. This is a high pressure sensor fault. It is the trip of the compressor overheat protection. Once again, we'll get the fault code readout and we'll get the flash on our LEDs to match up with that. So let's look at the fault codes on our drive. So when LED 3 is on, that means that we have some sort of fault code, some sort of an issue with the drive itself. So when LED 3 is flashing and LED 1 and 2 are off, this just means the compressor is preheating. You'll notice this when you first power it up, the compressor will go through a preheating. We're warming that compressor up before it starts. When LED 1, 2, and 3 are off, once again, this indicates there's no drive faults and the compressor is not in heat preheating. So the drive fault codes display in sequence at intervals of 5 seconds. This means an LED is off for 5 seconds to report if there is another fault code. So what we're looking for is no lights on there. We have no faults at that point. The fault codes that shows the timing here, just going to be a flash on and off. If LED 3 is on, then we're giving the flash code, and then we just have to look When they go off, if there is more than one, it'll give a pause before we go to the next one. It's again, not unlike what we're looking at when we're looking at fault codes on our furnace boards. So as an example, fault code number 1, this is an outdoor ambient temperature sensor fault. Number 2, outdoor coil temperature sensor fault. Could have a faulty sensor. We could have a loose connection. So we just want to look at that. Fault code 5 is cooling freezing protection because the indoor coil temperature is too low, or the heating overload because the indoor coil temperature is too high. Well, there is no sensor on the indoor coil itself. What it's looking at is it has sensors to look at the pressure and the temperature coming back and on our suction line and our liquid line, so it can tell if our suction line is too low, then it's assuming that our coil is freezing up. So we either have a low refrigerant charge, or we have our indoor coil is actually freezing up. Maybe we have a blower motor that has failed, or we don't have enough airflow through it or something like that. So there's not actually any sensors at the indoor coil itself. It's taking the sensing coming back on the refrigerant temperatures and lines to determine if there is an issue with the indoor coil. So fault code 14, the high pressure switch is opened. The outdoor unit has shut down for its high pressure. It's gone off on head pressure. Once again, we need to do a little work. Why did it go out on pressure? Once again, are we have a dirty coil, outdoor coil, or we could have a dirty indoor coil. So it gives us the fault code of why it shut down. It doesn't tell us exactly everything. This is where we come into play to determine why did it do that. So here's some other ones, 17, 18, and 19. Discharge temperature sensor fault. AC voltage is abnormal, means it's too high a voltage or it's too low incoming voltage. And there's if you want the full list, because there's a lot of different ones that it lists, just go to the installation manual and you can get the full list then. So when we finish on our installation, just like we do on any other unit we do, we fill out the startup sheets. Okay, the sheets are included in the installation manual. The installation sheets are available to download from the Solution Navigator website, or we can go into the DS Solutions app and we can do the installation startup directly off the DS Solutions app. If you're not familiar with the DS Solutions app, talk to your TM, talk to one of us, Don or I or Eric. We can help you with that, but the DS Solutions app is an app that you really need to have because more things are going towards that direction. You do have to have a login. It's the same login as what you use for your Solution Navigator website. And if you don't have one, once again, get a hold of us, get a hold of your TM. We'll get you a login, just your email address with a password to get into this, to be able to use Solution Navigator and to use the DS Solutions app. So there's more and more things going on to this DS Solutions app, from registration to your startup sheets. You can check warranty. You can look up parts. So there's a lot of things on this DS Solutions app. So once again, if you need some help with it, we can help you out. But it's a very good app that everybody should have. So with that, we whipped through that pretty good. I don't have much for questions. It looks like maybe I have one here. Is there an option for communicating control that will display all of those running performance details? No, there is not, because this just uses a standard thermostat. It's not communicating. I don't believe it has any intention to be communicating. It is a heat pump, just a standard outdoor heat pump that takes care of itself. So there is, at this point, I'm not aware of any fact of it becoming a communicating type of unit. So again, it just uses a standard heat pump thermostat. Is there a drain pan heater? I don't believe that there is. Don, do you know? I have not seen one being in there.
I do not believe there is,
I didn't
or at
think
least
there
I haven't
was.
seen one either. So we can
Okay.
we can check it out though.
Yeah, we can check into it, but I don't believe there is a pan heater in that. Anybody else with questions? Once again, you can unmute yourself if you want to ask the question, or you can put it in the chat, whichever you prefer. Have I missed anything there, Don?
Looks like before the questions, there was a comment about the stub outs being hard
yes.
to cut off.
Yeah. Once again, that the ones that we have on hand, currently have on hand, unfortunately, those are the ones that it's a little tough to get to and such. So on the new ones, we don't have the newer ones in yet, so I can't say for sure on what they're going to look like. But the factory was aware of the fact that there was an issue there, so they are to change that. Hopefully they're long enough to cut off the bell. I'm not 100% sure. I have looked at the 2 and the 5 ton, the ones that come off with the 45-degree angle, and those do have enough room there to be able to cut that bell off. On the 3 ton, hopefully they have changed that so that we can, but they were aware of the fact that there was an issue with it, but we didn't have very many on our first shipment just because they are brand new. But hopefully everything we get in now will be the newer versions to where hopefully everything is good then.
Hey, Steve, I got a question.
Yes, sir.
I may have missed it when you were going through there, but you were talking about line set. You know, you have the how much to put in with the line set, and then you talked about different coils. I know that was an issue with the Aspen coils. Do you have a amount that needs to be added if you go with a larger coil?
Yes, because the coils that we're using are going to be the York or Luxair coil. We're not using Aspen for these anymore. So
Okay. Will
so
that be
in the tech guide, pardon?
That's in the book, correct?
Yes, so in the tech guide, it will give you if you need to add any refrigerant, and it will tell you how many ounces you need to add if you're doing a little bit larger coil with it.
Okay.
So, so there will be an actual match between the JCI outdoor and the JCI indoor.
Okay, thank you.
So once again, it'll make it a lot easier, so we know exactly what charge we're going to need to put in there.
Gotcha.
Anything else with anybody?
There's a couple more questions popped up in the chat, Steve.
Okay. Here. What thermostat do you recommend? You can use any of the Honeywells or the Ecobee or the Pro One stats, anything that we sell, you can use. Just make sure it's a heat pump thermostat. And if you're using it with a furnace, it needs to have a sensor, outdoor sensor to go with it. So whether you're using a wired outdoor sensor or you're using a wireless outdoor sensor with the Honeywell, or if you're using an Ecobee, make sure you have internet access so that it's reading an outdoor temperature. And do the coils have stub outs to use the RLS fittings? Yes, they will be. Now, one thing I didn't bring up, I need to make sure you're aware of, is these do not come with a filter dryer. We should check, we should supply it. We should catch that to go with the unit, that there is a filter dryer with it, but double check to make sure that you do have the filter dryer to go with the unit. Now, the filter dryers we have the standard, if you want to say standard filter dryers with the standard connections. We also have filter dryers with the extended connections from RLS. So if you're using the RLS fittings, when you order it or whoever orders, make sure they let whoever they're ordering from, the counter people, know that you need the filter dryer from RLS or the filter dryer with the extensions so that you can use the RLS fittings. If you don't specifically ask for it, then more than likely you're going to get just the standard braze-in filter dryer. Is there anything else I missed, Don?
I don't see anything.
Okay. Anything anybody else has? All right. Well, you guys are pretty quiet, so I've expected a few more questions. So I figured it'd go a little bit longer than that. But if nobody else has anything, thank you and have a good day. I'll stay on here for a little bit, Don. I'll stay on here for a little bit if you do come up with some questions. But other than that, I appreciate your time, and hopefully in 2 weeks, if you didn't see the A2L the first time, you'll stick around for the A2L the second time around. Thank you. Have a good day.